The next step is to cultivate our bacteria. Previously, Ailey stored an extra sample of soil in the fridge. That's excellent for storing our bacteria for a short period of time, maybe 4 to 6 weeks. But we might have identified some other important bacteria from our earlier DNA extraction. To store bacteria for a long time, we can use liquid nitrogen or dry ice to cool our samples. This process is called snap freezing, since we're freezing our samples in the time you could snap your fingers. Abel will show us how it's done with liquid nitrogen. Abel pours the liquid nitrogen from an insulated bucket into a cool rack. Notice how the nitrogen has already started to evaporate, since nitrogen has a boiling point of negative 190 degrees Celsius. After 15 minutes, Abel can snap freeze the sample by adding it to the cool rack. When we want to grow our bacteria from the frozen sample, we only have to defrost the tube. Then, with a petri dish, a round plastic dish for growing microorganisms, Abel first pipettes some of the culture into the dish with a micropipette. Then, he uses a looped rod to spread the bacteria around. When the spread is complete, the lid is closed to stop any unwanted microbes from growing, and leaves them to grow in an incubator. When the bacteria have grown, they can now be checked under the microscope. Hello, Adam. Why don't you take a look down the microscope? And look at that! Bacteria! In real life, Adam would check for differences in how the bacteria grow, their natural colour, and what colour they return when certain dyes are added. Now, we've looked at quite a lot from the start, from collecting soil and storing it, removing soil clumps and purifying the samples, centrifuges and buckets of water, and adding a fluorescent dye to check for DNA. We then looked to identify which bacterial species we have in our sample, and then checking for antibiotics and metals in the soil. Good job, Adam, and goodbye.